Okay, this problem says a cruise ship with a mass of 10 to the power 7 kg strikes a pier at a speed of 0.75 meters per second. It comes to rest after traveling 6 meters, damaging the ship, the pier, and the tugboat captain's finances. Calculate the average force exerted on the pier using the concept of impulse. First, calculate the time it took to bring the ship to rest. Assume a constant. I guess here's a typo. We'll calculate the average force exerted on the ship by the pier, since we know the velocity of the ship. And then anyway, the force on the pier is the opposite force. So all right, so here's the ship going with an initial velocity, and then it comes to rest. And so the pier exerted a force on the ship in this direction. And the impulse momentum theorem says that average force times time is equal to final momentum is equal to change in momentum of the ship. And minus P initial. So this is the initial, this is the final. In the final instance, the ship has come to rest. Okay. So, and so the negative sign is just telling you that the force is in the opposite direction of the initial momentum. Okay. So that's what the negative sign is telling you. Okay, so the average force is initial momentum over the time over which the ship was stopped. Okay, so let's solve for the time over which the ship came to rest. So, well, this will be a two-step process. V square equal to V naught square plus 2a delta x. We'll solve for the acceleration. Acceleration is v square minus v naught square over 2 delta x. The final velocity is 0. Initial velocity is 0.75 meters per second. So square, and the ship was stopped over 6 meters. Okay, so the acceleration of the ship is is 0.05 meters per second squared. And now to calculate the time, final velocity is initial velocity, acceleration times time. This is 0, this is 0.75, and the acceleration is negative, by the way. Minus 0.05 times t. So this ship is brought to rest in 15 seconds. Okay, now we are ready to calculate the average force, so we'll substitute this in here. Okay, so let me add a page. So the average force is negative. Again, the negative sign just telling you that, giving you the direction of the force, which is in the opposite direction of the ship was moving in this direction and the force was in that direction. Divided by delta t. So this is the mass of the ship is 10 to the 7 kgs. Initial velocity is 0.75 meters per second, and the time was 15 seconds. And so this works out to minus 5 into 10 to the power 5 newtons. Okay, so that was the force exerted on the ship by the pier. Okay, and that finishes that problem.